Okay, so let's start this one. So again, I'm going to try to prove something. I'm going to try to prove that tan x plus cotan x, whole thing squared, equals secant squared x plus cosecant squared x. So I'm going to go ahead and start on this side because that looks more scary to me. It's an entire binomial squared. And I'm going to break it down to sine and cosine. So tan x is sine of x over cos of x. Cotangent x is opposite. Geez, had to think for a minute. That's still being squared. I'm going to find a common denominator. So I'm going to multiply this by sine and this by cos of x all the way through. So I'm going to get sine squared x plus cos squared x all over cos x sine x. And again, hopefully this is the identity I remember. That equals 1. So again, this whole thing was squared. So it's still being squared. So I get 1 over cos squared x sine squared x. Well, crap. That did not come out to look like this, right? I'm not really sure how to break this into two different things then. So maybe I should start working on this side also. Again, not moving anything, just kind of simplifying it. So secant squared x is 1 over cos squared x. Cosecant is 1 over sine squared x. I can find a common denominator. I'll multiply this one by sine squared. Multiply this one by cos squared, so that way my denominators look the same. So I'll get sine squared x plus cos squared x all over sine squared x cos squared x. And hopefully you see where this is going. Sine squared x plus cosine squared x just gives me 1. So 1 over sine squared x cos squared x. So I got two sides look the same, again working with them individually, so proved.